Good morning. Welcome back to which we've been working on. So today what we're going to do is take the next step in what we had worked on last time by solving systems of linear equations by elimination. So if you remember last time, what we did is we looked at the variables and we tried to look at the coefficient for the variables, and we wanted the coefficients to be basically the same number. If there's a negative in front, it doesn't really matter as much. We're just looking for the number. So if you remember something like this, I would look at both x's. The coefficient for both x's is 2. Then what we have to do is figure out, okay, how are we going to eliminate? So we have a 2x and a negative 2x. So what operation do I need to get this to become a 0? So if I add 2x and negative 2x, that becomes 0. And then we were just adding each part individually. So y plus 2y is 3y, and 4 plus 5 is 9. Divide both sides by 3, and y becomes 3. And then what we did is we just substituted it back into one of the equations. In this case, I substituted into the first one just because my life was a little bit easier. And that's right here. So 2x plus y is 3, so we just put in 3 equals 4. Subtract 3 from both sides. We get 2x equals 1. Divide by 2 from both sides, and we get x equals a half. So the question is, what happens when the coefficients are not the same? So if you notice here in front of the x's, we have a negative 6 and a negative 2. Here with the y's, we have a 5 and a negative 4. Well, we're going to use a concept that you learned in 5th grade. Yes, do you remember adding fractions? Well, we're going to use the exact same thing. So going back to adding fractions, if you remember, you have to have a common denominator. Okay, so for example, for this one, we need to get a common denominator of 15. So we multiply the first one, 2/5 by 3, numerator and denominator by 3, and we come out to have 6/15. And then we multiply a third, numerator and denominator by 5, we get 5/15. And then we can go ahead and add them. But the key was getting that common denominator. Well, we're going to do the same thing, but instead of getting a common denominator, we are going to be getting a common coefficient. Okay, so we're going to look here. We have the x's, we have a negative 6 and a negative 2, and the y's, we have a 5 and a 4. So what we want to do is get the two coefficients to be the same. So it's probably easiest to get the x's to be the same. How come? Well, oops, I don't know why that just happened. Well, let's look. We have a negative 2. We can get that to be a negative 6 very easily just by multiplying by 3. Now here's the part that's kind of neat. What we're going to do is we're going to multiply the entire equation by 3. So we're going to do negative 2x by 3. We're going to do negative 4y by 3. And we're going to do 14 by 3. Okay. All right, so I'm just going to rewrite the top one so it's easiest for us to add them or subtract them, depending upon what we come out with. So 3 times negative 2x is negative 6x. 3 times, really it's a minus 4y, so that would be minus 12y. 14 times 3 is 42. Okay, so now we're exactly where we were the other day. We now have coefficients are the same. So now I have a minus 6x and a minus 6x. So how am I going to get rid of a minus 6x? Well, I need to subtract the same thing. Okay, so minus 6x is 0. Now I have a 5y. This is the operation I'm doing right here. So I'm taking a 5y and I'm subtracting a negative 12y. So 5y minus negative 12y. So it's really adding 12, comes out to be 17y. And now I'm going to subtract these two. So 42 minus 25. Actually, it's 25 minus 42, but we know we're just taking the difference of it. So that would be 17. Since this is the bigger number, it's going to be negative 17. So 17y equals negative 17. Obviously, divide by 17 here. So y is going to be negative 1. Now, we don't do anything different at all to figure out what x is. We're just going to plug in negative 1 into one of these equations. Doesn't really matter. I'll just put it into the first one. So negative 6 plus 5 times negative 1 equals 25. So multiply that through. Negative 6x minus 5, equals 25. You're going to add 5 to both sides. So you get negative 6x equals 30. Divide both sides by negative 6. And x is negative 5. Okay. So just in a quick review, we didn't really do too much different than what we did last time. It's just that we needed to get the coefficients of one of the variables to be the same. How do we do that? We multiply the entire equation by a number. Now we can do it to both depending on what it is. We'll see that in the future. Okay, so now let's look at this one. There's two ways we can go with this one. Okay, if we look at our x, we have a 3 and a 6. That's not that complicated. Here we have a 1y and a 3y, so we can really multiply this one either by 2. That will give us a 6x, or we can multiply it by 3, and that'll give us a 3y. Doesn't matter. I'll do it. What did I multiply the last one by? I multiplied the last one by 3, so I'll do this one by 2. Actually, you know what? I'll do this one by 3 again, just because you can see that you can do it to y as well. So 3 times 3x is going to give me 9x. 3 times y is going to give me 3y. And that equals 3 times 11, which is 33. Okay, let me just write the other one underneath it. So that way we can see what we have to do. That equals 24. Okay. So now I have a 3y plus a 3y. So the only way for me to eliminate these is to subtract the two of them. So now I'm going to subtract this bottom equation from the top one. So 9x minus 6x is 3x. There's a lot of 3's in these. 3y minus 3y is nothing. Okay. 33 minus 24, in this case, is 9. Divide both sides by 3. X is 3. Okay. Oh, yes, x is 3. Now let's solve for y. Plug the x into, let's do the top one, because that way there's only one y there, so we don't have to worry about any dividing. So 3 times x, which is 3, plus y is 11. Okay, so 9 plus y is 11. Subtract our 9 from both sides. Y equals 2. Okay. So again, all you have to do is multiply one of the equations, sometimes both the equations, so you can get a coefficient that's the same. So that leads us to this one. How are we ever going to use this in your life? Well, it kind of depends on what you're trying to find. So this is a situation that you might have. So let's say you buy, and now these are plants, so I didn't put the pictures in. I probably should have, but it is what it is. So you buy 8 hostas and 15 daylilies, and it costs $193. Your friend buys 3 hostas and 12 daylilies, and it costs $117. Find the cost of each daylily. Now you're like, okay, how does this work with what we just did? Well, we're going to take this equation and turn it into something that looks just like this. Well, how are we going to do that? Well, we have unknowns. A variable just stands for an unknown. So we don't know how much the hosta costs, and we don't know how much the daylily costs. But what we do know is, how many hostas we get here and how many daylilies we get here, and what the total price is. Now your friend is going to pay the same amount for the hosta and the same amount for the daylily. So those are going to be our variables. If you notice, we have 2 unknowns. So we'll just call the hostas x and the daylilies y. We could have switched around, doesn't really matter, just one of them, just as long as we're consistent. Okay. So this would turn into something that looks like this. First equation is, okay, 8 times the price of the hosta, which we called x, plus 15 times the price of the daylily, which we're just going to call y, and that's going to equal 193. Okay. Now your friend gets 3 hostas, so that's 3 times the unknown value, which is X for the hostas. And he gets 12 daylilies, and that's the price we don't know is, but we'll call that Y, and that cost 117. And it asks us for what is the price of each daylily, so really we only have to find Y here. All right. So here's the equation. Now what we have to do is we have to get the variable to have a common coefficient. So we have to look at X and we have to look at Y. And this is just like when we were trying to find common denominators when you're adding fractions. You just have to find the least common multiple. So 8 and 3, the least common multiple between the two of them is 24. Not so bad. This one, 15 and 12, the least common multiple is 60. But we don't want to eliminate this one because we're trying to find that one. So we really want, in this case, we really want to get rid of the x's. So we need to get the least common multiple, which is 24. So how are we going to get each one of these to 24? Well, 8 times what is 24, and that's 3. 3 times what is 24, and that is 8. So we're going to multiply the entire first equation by 3 and the entire bottom equation by 8. Now, don't get nervous. The numbers aren't that bad because you all have a calculator that you can use. Okay? Listen, I'm not doing 193 times 3 in my head. Calculator does it for me. So I'm going to come over here, write it out. So 3 times 8 is 24. So we have 24x. 3 times 15 is 45. So 24x plus 45y. 193 times 3 is 579. Let's come to the bottom, multiply everything times 8. So 8 times 3 is 24. So we have 24 x's. 8 times 12 is 96. 96y. 117 times 8. Plug it into your calculator. You get 936. Okay, and we're going to do the same thing we did before. There's nothing different here than what we did here. It's just that these are not numbers you can do in your head. Fine, not a big deal. Use your calculator. So how do I get rid of the x's? Obviously, I'm going to subtract the bottom equation from the top. So 24x minus 24x is 0. 45y minus 96y. Plug it into your calculator. You're going to get negative 51y. 579 minus 936. Again, plug it into your calculator. That comes out to be negative 357. Okay. Now listen, whether this is a 3y, an 8y, or negative 51y, we're still doing the same exact thing. You divide by the coefficient. Do it to both sides. Plug it into your calculator. Negative 357 divided by negative 51 is 7. Okay. So since all we had to do was find y, we're done here. So the cost of each daylily is $7. Okay. So just like we did last class, what you're going to need to do for me is take a picture of your work and put it into the assignment that I created. Just do me a favor this time. Most of you did a really good job with this, but just look at your picture before you upload it because a couple of them were a little blurry, a little hard for me to see your work. Main reason why I'm doing this is so this way I can, if you're making a mistake, I can see what it is and I can help you. It's a good thing like that. So good luck. I will have GoGuardian on. Let me know if you need any help. Just send me a little message. Good night. Oh, good day.